Hey guys, these are the questions that I'd like to go over today, just a little bit more practice with quadratic functions, specifically vertex form, and we are going to do a couple word problems applications on page 184. So make sure you have a textbook, just try to follow along. At certain points during the video, I'll just say pause so you can try the question on your own, and then you can press play to just kind of double check everything and make sure you're on the right track. The first couple questions that we're doing, the 34 to 38 even, are similar to the questions we did yesterday. So if you look at the directions, you're trying to convert this into vertex form using completing the square. So instead of completing the square, I'm going to show you a different method you can use to rewrite a quadratic in standard form into vertex form. It was good yesterday just to do the practice, but I know there are people who really hate completing the square, so if you are one of those people, this might be a better option for you if you're trying to convert it into vertex form. So in number 34, our function g of x equals x squared minus 6x plus 12. We do know one piece of information already, so we're trying to convert this into our vertex form, which is a times the quantity x minus h squared plus k. We already know a. When we talk about the different forms, if something in standard form has an a value of 1, when you convert it to vertex form, the a value is still going to be 1. So the good news is we have one piece already, we just need to find what the vertex is. And there is a way you can find the vertex from standard form, you just have to use the axis of symmetry formula first. So we'll start with negative b over 2a. So the opposite of b would be 6 over 2 times 1. We get 3. So if we plug this back in, we're looking for g of 3, which means we're just going to replace all of our x's with 3 and simplify. So if we square, multiply, add like terms, we are looking at a y value of 3 also. So our vertex is 3, 3. Our a value is 1. So if we combine everything together, we would have 1, which you can write, you don't have to. X minus 3 quantity squared plus 3. So at this point, I'd like you to try 36 and 38. You can just pause the video here, try it on your own or with your partner. When you're ready to check your answers, press play. Okay, number 36. Number 36, we're looking at h of x equals 8 plus 2x minus x squared. You can rewrite this so it's in proper standard form if you'd like, but we do know a and b already. Okay, so a would be negative 1. To find our x coordinate, we'll use negative 2 over 2 times negative 1. And then plug it back in to our function. So if we plug in 1, everything simplifies to just 9. So our vertex would be the coordinate 1, 9. So our a value comes first, then our h value, then our k value. Okay, last one like this, number 38, we have g of x equals 5x squared minus 25x plus 12. So we know our a value already is 5. We'll find the x coordinate of the vertex, or the h value. If you would choose to use decimals here, that is okay. Okay, I would take either form, unless the decimal is a repeating decimal. Okay, switch it to fraction form if that happens. So if we plug in 5 over 2, we get negative 77 over 4. Don't forget the squared. Okay, it's still important to make sure you have that exponent. And that is that. So like I said, completing the square is a good method to know, but I do want to at least give you some other options just to make sure that you get it. The other two questions I'd like to go over with vertex form is number 43 and number 44. So if we start with 43, we're still trying to write it in our vertex form, but we have different information. So we actually have the vertex already. Okay, in number 43, the vertex is 1, 3, which means our h value and our k value are given. We also have some other random point. So the other point on our quadratic is 0, 5, which we can think of as a random x and y. So the only thing we're actually missing is a. And we have everything we need to find a, we just have to plug it into the correct spot. So in our vertex form, we start with y, so I'm going to start with the y value that's given to us here. Do not use the vertex. They have specific places for h and k. Okay, a is unknown. Our random x coordinate is 0 minus our h value. Make sure you have the squared, and then bring down k. Once you have everything plugged in, all you're working on is simplifying, use order of operations, get a by itself. So we can subtract the 3. This is negative 1 squared, which is just 1. So a is going to equal 2. So then put it all together. A comes first, and then our vertex. All right, so at this point, pause the video, try number 44. Okay, when you're ready to check your answer, press play. Okay, so if we're looking at negative 27 equals a, negative 4 plus 2 quantity squared minus 5. We could add the 5 over first. Simplify, this is negative 2 squared, which just become a positive 4. So a is going to be negative 11 over 2. Put it all together. Make sure you check your signs, and you're done. At this point, if you have any questions on vertex form, jot it down. You can always try some of the odd questions in the textbook. The answers are in the back. So I've tried to do a lot of the evens, so you have a chance to try if you need to, and then you can check your answers in the back. There will be some practice, especially with this type, because it's kind of newer than what we did yesterday on the homework tonight. But see what you think, jot down questions so I can go over them tomorrow. At this point, I would like to go over some of the word problems. So we are going to focus on just 4 of them in the textbook, and then you will have 4 to try for homework tonight. So we're going to look at, 54, 58, 59, and 61. Okay? So 54 is looking for a maximum area. Right away, if you know you're talking about quadratics and you're looking for a maximum, I do want you to keep in the back of your mind that what we're actually looking for is the vertex. Okay, so we're going to get some sort of quadratic that opens down so that the vertex is at the highest point, which means it's the maximum. So we are going to be using the axis of symmetry formula, or you could use maybe some of your graphing techniques with the calculators. In this question, we're looking at the perimeter of a rectangle, and we're only given that piece of information. We're saying that we want to find the maximum area of a rectangle that has a perimeter of 100 feet. That's really what it's saying. We don't know any of the dimensions yet, but that is what we're trying to find. So since we don't know any of them, I'm just going to say one of the sides is x, which means the opposite side would have to be equal, which is also x. So if I only have 100 feet of fencing to use, I've already used twice of whatever x is. So if x was 10, I've used 20 feet. If x was 30, I've used 60 feet. So to represent that with x, since I don't know what it is, we're going to subtract both of them. So we had 100 feet, now we have 2x less. This needs to be split between the other two sides. Okay, we have all 4 sides to build. So if we need to split it, I'm going to divide it in 2, which means the other dimension is 50 minus x. Okay, once we have all of our dimensions, we can find the area, which is length times width. And once we have our function, we can find the vertex. Remember, this is just the x-coordinate, which really isn't what we want. It's just saying one of the sides is, or one of the dimensions is going to be 25 feet. If we want the maximum area, we're going to have to plug it back in just to figure out what the maximum is, which is the y value. So in this case, we get an area of 625 square feet. So if you are looking for the dimensions, we know that this one is 25, and if you plugged it in here, it'd be 25 by 25. So anytime you're building this from scratch, a square is actually always going to have the maximum area. Just a fun fact. Okay, next one, we're doing 58. All right, 58 is probably familiar. I'm just gonna slide my book down just so I can kind of see it a little bit easier. 58 is a question I bet you've seen in Algebra 2, especially if you had me. It's a type of question that we talked about. So if we're talking about income, remember, income is going to be taking the number of items that you sell times the price per item. Okay, so that's kind of more of the common sense part of it, but now we have to build these two expressions. So we're gonna have an expression for the number of items and the expression for the cost. Okay, so in this case, we're talking about units. So the fact that there are 1,600 units available isn't necessarily relevant at this point, because all we need to know is what's happening currently. So there's currently 800 apartments being rented, and they are being rented for $300 per month. So what's happening in this situation is we're talking about an increase or a decrease in the price and how that affects the number of apartments. So a survey indicates that a $5 decrease, so if we subtract $5, results in an increase of 20 leases. So what's going to start to happen each time that we decrease the price, we're going to gain more homes. So we have to think of X as the number of times we decrease it. So they're looking for what's going to give them the maximum profit or the maximum income. So we kind of have to think about each time they decrease it, what is happening. So X is going to be the number of decreases. So how many times should we subtract $5 until we get the maximum? So we know the current number of items is what we start with. So 800 apartments is what we started with. And what's happening each time is we're adding 20. So X is like the number of increases. So each time we increase, we get 20 new ones. The price was 300. Each time we decrease the price, we're subtracting $5. Okay, so if you are graphing and choosing to use graphing as your method, this is actually as far as you need to go, technically. This is in factored form. It's not completely factored, but it is in a form of a quadratic. So especially if you're trying Desmos, this can be typed in and then look for the vertex. If you want to multiply it out, feel free. You can multiply, distribute, add your like terms. We get negative 100x squared plus 2,000 x plus 240,000. Okay, so this is the standard form for our quadratic. And if it's in standard form, we can use negative b over 2a. So negative 20 divided by negative 2. The management company should plan on decreasing the price 10 times. That's all this means, not $10. We're just decreasing it 10 times. If we want to find out what the income actually is, we can plug this 10 back into our function. And if we do that, we get a max of $250,000. Okay, so that's kind of A and B. So I know the textbook says for part B to graph it, and you're more than welcome to. But keep in mind, you're gonna have to definitely adjust your window. Your maximum here is at 10, 250,000. So Desmos might be nice because you can easily zoom in and out. If you're using a graphing calculator, you'll need to switch your window. So it's on that top row with everything else. The last part is what rent. So what should the rent actually be? So the rent was $300. We're gonna decrease it by $5 10 times. Okay, so really we're just kind of plugging it back in for X, just for the rent. So if we subtract 50, a rent of $250 will yield a maximum income. Okay, 59 is a similar problem. So I would like you to try it. Feel free to pause the video so that you can check your answers when you're done. Okay, so in this case, we're talking about soda cans. So they're selling 26,000 per month currently. And if they increase the price, they're going to lose, well, they're predicting, they're gonna lose 1,000 per month. The price is 50 cents. We are increasing it by a nickel, which would be 0.05x. Okay, multiply it out, standard form. If we found our x coordinate, we would get positive 8. So this is saying they could get a maximum income if they increase the price 8 times. That income would be 16,200. And the cost per soda, we're looking at originally 0.5. And then we're increasing it 8 times. So we get 90 cents. Okay, the last question that I want to go over is projectile motion. So you're looking at number 61. There are 2 formulas that you can think about. It's not necessarily something you have to memorize. It's usually pretty easy to put it together. When you're talking about motion and projectile motion, a lot of the times you'll see something like h of t because you're talking about the height as it relates to time of -1/2 g, I'll do positive 1/2 g t squared plus v sub 0 t plus h sub 0. So when you're looking at this, the 1/2 times g is going to be your gravity, which ends up being negative. So gravity, it depends on what your unit you're talking about. Could be -32 feet per second squared. Okay, our acceleration due to gravity. Or if you're using meters, -9.8 meters per second squared. This is your initial velocity. And this is your initial height. So it's not super complicated. All you're gonna have to do is plug in the information from the problem. So in this case, our initial height is 83 feet above the field, and the initial velocity is 92 feet per second. So if we're talking about feet, this is what we want to use for gravity. Okay, keep the units the same. So our function of height is going to be negative 16t squared plus 92t plus 83. Okay, so this will be our function to model the height versus time of the baseball. So if we want to find the maximum height in part A, remember max is vertex. So you are more than welcome to look on the graph, find your maximum on the graphing calculator or Desmos. If you're doing it by hand, or t would be negative 92 over negative 32. Okay, which is 2.875 seconds. So if we round up after 3 seconds, the ball would be at its maximum height. We don't know what it is yet, so plug it in. So h of 2.875, we equal about, so I'll say about 215 feet. All right, part B. What is how much time is the ball in the air? Okay, so we have, if this is our 83 feet high, okay, and we're throwing the baseball up and it's coming back down, landing on the ground, this is how long it's in the air. So what we're actually looking for is a 0 or an x-intercept. So what we could use is the quadratic formula, especially because this does not look nice. I'm pretty sure this is not factorable. Completing the square would not be ideal. So quadratic formula is probably the best method, or look on your graphing calculators, find the 0, okay? Keep in mind it is good to try both ways. I'm not going to necessarily make you do both here, but sometimes you're going to need to know how to do the quadratic formula with decimals, so I recommend you try it if you haven't recently. The nice thing, because it is a word problem, I don't want exact answers. So I do want the decimal, which means you can just plug this whole square root in your calculator. I think it's like 13,776. So the square root is going to be some decimal round. Okay, and then you can add, divide by negative 32, subtract to the numerator, divide by negative 32. We get negative 0.79 seconds or 6.54 seconds. Pick the positive answer. Okay, so there's your answer for part B. Part C, vertical velocity. This is on page, page 180 of your textbook. So if you want to look at the formulas, I forgot to mention that, they are just a couple pages back. So you can kind of look into how they use it. The vertical velocity formula is V of t equals negative 32, since we're talking about feet, plus the initial velocity. So if we fill in our time, so we're looking at the vertical velocity when it hits the ground. So our time of when it hits the ground is the 6.54. And then our initial height was, or initial velocity, sorry, is 92. So if we multiply and add, we get about negative 117. Okay, so at this point, jot down any questions you might have about the word problems. There are 4 on the homework for you to try. Feel free to try some of the other ones. I went over the ones that I like the best, but feel free to try some of the other word problems in the textbook also.